Hi everybody. Today we're going to be talking about geometric sequences and exponential growth and decay. These are the types of things that we've actually already done with Thanos and with the zombies, and you also did this last year. All right, so the first thing that I want to make sure everybody knows is that exponential equations and geometric sequences are basically the same thing. They're just maybe different looking problems, but they're the exact same thing. They have the exact same type of equation. So just like a line has y equals mx plus b, exponential equations have y equals a times b to the x. So it'll always have this format, no matter if you're talking about interest, no matter if you're talking about Thanos snapping people into dust, no matter what it is, it's always going to look something like this. So let's look at our first example. So every time Thanos gets someone in the circle game, so you know what I'm talking about, 35% of the people in the world are turned to dust. So you guys probably know the consequences of the circle game for a normal mortal, but when you have the infinity gauntlet, apparently it's a lot worse, and when you get somebody, it's 35% of the people in the world are turned to dust. So let's see if we can model that depending on how many times he gets somebody, how many times he gets somebody with the circle game. So our independent variable is going to be x. That's going to be the number of times he gets somebody. And then we'll say y is going to be the number of people. So y is the number of people left. And x will be the number of times let's just say he wins the circle game. He gets somebody with the circle game. So we want to know how many people are left in the world after he gets 9 people in the circle game. So the first thing to think about is you want to think about what happens before he even does anything. So after he gets somebody 0 times, he's won no times, he hasn't gotten anybody yet, that's going to be 1,000 people left. So that's really important, is that it doesn't start on 1, it starts on 0. That's going to be a really, really common theme. So we're always looking to when is it 0? So at time 0, you could say there's 1,000 people left. Then we could look at time 1. We have how many people left? So a lot of people would say, well, you just do 1,000 times 0.35 because it's 35%. But that is not correct, because that's how many people we're losing. We want to know how many people are left. And how many people are left if you lose 35%? You just do 1 minus 0.35. You could probably just do it in your head. If you lose 35%, how many are left? That's what's really important. How many are left? And that would be 65% remain each time. So we're going to be multiplying by 0.65 each time. So we're going to do times 0.65, and we're going to get 650. So that one I can do in my head. And then we would just keep doing that. We would do, on the second turnaround, we would do 650, we would do 1,000 times 0.65 times 0.65. Assuming that I didn't know what it was for 1, I'm just going to go all the way back to 0 and start with 1,000. So let's see what that is. I'll put that in my calculator. And we get 422.5. So I don't really know what happens with that person, if it's just a half a person or if it rounds down or rounds up. I don't know how the infinity gauntlet works. Nobody's ever given me a chance with it. And then we would just keep doing that, right? So for 3 people, it would be 1,000 times 0.65 times 0.65 times 0.65. So essentially, you start with the 0th term right here, and you multiply by that common ratio, the common multiple, however many times that it says for x. So that's why our equation becomes y equals a times b to the x. And in this case, it would be y equals 1,000, which is our starting value, our 0th term, times b. Our b is 0.65, to the x. So the part that a lot of people will get wrong is they'll put 0.35 in here for your b, but it's not. You want to think about what remains. So notice how in this entire problem it never says 65%. You have to know that since you're losing 35%, you're keeping 65%. Let's do a couple more examples. Let's skip these for now. So let's write an equation for a couple of these right here. So we want to write an equation for each exponential or geometric sequence. So when it's written like a sequence like these are, a lot of times they say the word geometric instead of exponential, but it really just means the same thing. Geometric just means multiplying over and over. So let's just think about it. We're always going to do y equals a times b to the x. Every single equation is going to look like that. So let's see here. Our term for this one is our 0th term. And remember, a is always your 0th term. So our 0th term is 3. So 3 times, and then what are we multiplying by each time? Well, it looks like we're multiplying by 3 there, and then we're multiplying by 3 again. So we get 3 times 3 to the x for this one. Let's look at the next one. So the next one, we start with 64. So that's our first term, actually. So we don't even know what our 0th term is. Notice how in number 1, they told us what our 0th term. Our 0th term is 3. But in number 2, we have to assume that 64 is actually the first term. So your 0th term would be, back here somewhere. We'll figure that out maybe in a second. Let's figure out what we're multiplying by each time. A times b to the x. So what's our b? What are we multiplying by every time? Let's just start in the middle somewhere. Okay, what do you got to multiply negative 32 by to get 16? So it's definitely going to be a negative because it changed from negative to positive, so it's going to be negative. And I think it's going to be 0.5 or like a half. Let's see if it holds. So 16 times negative 0.5 is again the right thing. So it looks like our b value is negative 0.5. So that's kind of a weird b value. And then a is, we need to figure out what our a is. Our a is our 0th term, way back here. So what number would this have to be in order so that when you multiply by negative 0.5, you get 64? So I guess what I would just do is, what's the opposite of dividing by a half? That would be multiplying by 2, but multiplying by negative 2. So I think this number is going to be negative 128. So our a value is going to be negative 128. So y equals negative 128 times negative a half to the x. Number 3, you start with $10 and it multiplies by $2. It multiplies by 2 every year. So you're not gaining $2 every year. Your money is literally doubling. So you start with $10. We can assume that that's at time 0. And you multiply by 2. How many times do you multiply by 2? Well, however many years there are. So our equation would look like that. Okay. Let's talk about what this looks like when we graph them or have equations. So you noticed in some of the previous questions that sometimes it goes up exponentially and it goes up faster and faster. It can also go down exponentially. And actually exponential, we call that exponential decay, it goes down slower and slower. So it either goes up faster and faster for growth or it goes down slower and slower for decay. So looking at this one, you deposit $200 in a bank account. Every year that account increases by 12%, which is insane. That's a huge interest rate. So you would be very rich very quickly. But let's just write the equation. So $200 is the initial amount times, okay. So do we multiply by 12 every time? No. We don't want to, it's not like our money is multiplying by 12. We're just gaining 12% each time. So you have to think, what do you multiply by to earn 12%. So a lot of people think, oh, you would multiply by 0.12. But if you multiply 200 by 0.12, that would be a pretty small number. That would only show you how much interest you get. And we don't want to keep track of how much interest you're getting. You want to know how much money you have total. So it's not this. So what it's going to look like, since it's growth, you are keeping 100% of your $200 and you're gaining 12%. So your decimal is actually going to be 1.12. That's essentially 112%. So you're keeping 100%. There's your 100% keeping. And you're also sort of keeping or gaining another 12%. So that's 112% total that you're getting each time. So that would be our equation. Look at it this one. Population of apartment building is 4,000 people. Every month the population goes down by 12%. So it looks like they're losing people this time. So our initial value is 4,000. Our growth factor. So our growth factor is what are we multiplying by each time? Would we multiply by 12? Would we multiply by 0.12? Let's try it. So let's do 4,000 times 0.12. I'm just going to do that on my calculator. It's not that much more than I think 400. So we do 4,000 times 0.12 and we get about 480. So is 480, that's 12% of 4,000. But let's say you're losing 12% of your people every month and you start with 4,000 people and then the next month you only have 480 people. Is that a 12% loss? No, that's not a 12% loss. This is 12% of 4,000. So that's actually what you're losing the first month. So this kind of goes back to the problem with Thanos in the beginning. What are we keeping each time? We want to think about what we're keeping, not what we're losing. It's kind of like you're staying positive. So our growth factor is actually going to be 0.88. We are keeping 88%. Right? Look on the bright side. You're keeping 88% of the people in your apartment. So our equation will look like this. Y equals 4,000 times 0.88 to the x. So a lot of people sometimes have problems with these decay things where the numbers are going down. But it's always just think about what you're keeping, always. Okay, so you start a bank account with $500 and the interest on the account is 8% every year. So let's just go right to the equation. Y equals your 0th term, your starting amount, 500 times, okay, we're gaining money. Okay, so we're gaining money. So this is going to be not 0.08, it's going to be 1.08 to the x. Why 1.08? Because you're keeping 100%. That's what you're keeping. They're not taking away your $500 and giving you 8%. They're giving you back your $500 and you're gaining 8%. So in total, essentially, you have 108% of what you had at the beginning. And you'll just keep doing that over and over and over again, and that money is going to go up real fast because 8% is a pretty good interest rate. Okay, I want to talk just real quickly about graphing. Graphing these is really easy. You're just making a table, and it's a lot easier than graphing parabolas because there's only one place to plug x in. So what I would recommend is at least start with like -2, -1, 0, 1, and 2. If they don't give you x values, maybe just use those. Okay, so let's start with the easier numbers. So let's say x is 1 down here. So that would be 1 times 3 to the 1. And we know 3 to the 1 is just 3. So we do 1 times 3, which is 3. So our first value is going to be 3. Okay. 2, let's try it. 1 times 3 to the 2. So 1 times 3 to the 2, that's just 1 times 3 squared, which is 9. So we got 9 for our second value. Right there. Okay, let's do 0. So 1 times 3 to the 0. A lot of people get confused on this. 3 to the 0 itself is just 1. So this basically says 1 times 1, which is 1. So we'll put that in there. So 0 goes to 1. Something I want to point out before we get into these other problems is notice that the numbers are tripling every time, right? Because that's our common ratio, 3. That's what's happening every time. We start with 1, it becomes 3, because 1 times 3 is 3. 3 times 3 is 9. The next number would be 27, and then it would be 81, and it would just keep going. It would get really big really fast. So let's look at negative 1. So 1 times 3 to the negative 1. So this is a negative exponent. Sometimes people have trouble with these, but a negative exponent just means a reciprocal. It just means I'm on the top, but I should be on the bottom. So what 1 times 3 to the negative 1 means is it means 1 times 1 over 3 to the 1. So it's basically just 1 times a third, which is just a third, which is going to be pretty small. I'll do it in blue. It's going to be very small, 1/3, right there. Okay, and again, we're keeping that tripling, right? A third times 3 is 1, 1 times 3 is 3, 3 times 3 is 9. So this previous one here, you could do this a couple different ways. You could say, all right, just work your way backwards. If this is multiplying by 3 every time, just divide by 3 to go backwards, and you can get 1/9. So it's going to be, again, very, very small over there. The way you could do this also is you could write 1 times 3 to the negative 2, which means 1 times 1 over 3 squared. Right? That's what a negative exponent means. It means put me on the bottom. So this is 1 times 1/9, which is 1/9. So then we have something that kind of looks like this. Something interesting is over here on the left. I think if you think about this for a little bit, that is never going to reach 0. Because you can keep dividing these numbers by 3, and it's never going to reach 0. All right. So that's pretty much what we need to know right now for exponential equations and geometric sequences. So make sure you're working on your homework, make sure you're checking your answers, and I'll see you next week.